Everybody, in this video I'll show you how the least squares method for finding a best fitting line works. We will only discuss the principal idea, but not the details and not the formula. Instead, we will focus on the interpretation of the regression line. The name least squares method comes from minimizing the MSE, so the mean squared error. What is the mean squared error? It is the sum of squared vertical distances between the points and the line, and this sum is divided by the number of points. What do we mean by that? If we consider the diagram that you see here, we have 4 points, and I'm now just trying to find a line which could be the best fitting line. Let's assume that it's maybe like this. This could be the best fitting line here, and the vertical distances between the points and the line are visible, for instance, from this point vertically to the line. Sorry, I'm just switching colors. Vertically to the line, vertical distance to the line, vertical distance to the line, and the same here. So the MSE, you take each of these distances, square them, add up these squares, and then divide by the number of points. So in this case, divide by 4. And the best fitting line is just a straight line, so a straight line with the formula y equals a times x plus b, with slope a and y-intercept b. But a and b are not just arbitrary parameters, but they are chosen in a way that the MSE that is produced by this line is less than the MSE that would be produced by any other line. For instance, let me just draw a line which is definitely not the best fitting line. This one, obviously, it's a bad line, and you see that the distances between this line and the original points. So, for instance, the distance from this point to the new line, from this point to the new line, from this point to the new line, and from this point to the new line vertically, these distances are far bigger than the distances between the points and the true best fitting line. So let's put that away again. So that's the best fitting line, and it's characterized by the MSE being the lowest possible MSE that you could create from these 4 points. So you have the equation of a line. You can find that with your calculators, the parameters a and b, and they are chosen in a way that the MSE is minimized. Now let's go on to the parameters and to the interpretation of these parameters. So a is obviously the slope or gradient of this best fitting straight line, and if we try to interpret the gradient in a specific context, then of course we will have some variable measured on the x-axis and another variable measured on the y-axis, and the interpretation of the gradient would be that whenever the x is increased by 1, so by 1 unit, if you increase x by 1 unit, then you expect the y value to increase or decrease, if it's a negative gradient, by exactly that a units in y. So if you increase x by 1 unit, then you would expect the y value to increase by a units. Whenever x is increased by 1 unit, you expect the y to increase or decrease by a units. So a, the gradient. Well, so you expect that, and of course it's only happening on average. Because if you look at the points, it doesn't happen for any point, but it happens on average. Well, that's the interpretation of the gradient, and the interpretation of the parameter b, the y-intercept. You could say that if x is 0, then you would expect y to be whatever this b means. So the y-intercept, its interpretation is, if x is 0, then we expect that y equals b, which is also only true on average, so it's what we expect, and it's only applicable if the x value 0 is within the possible range of the data. So if your data is only between 100 and 110 on the x-axis, then you will not be able to interpret the y-intercept, because the y-intercept talks about when x equals 0. So the y-intercept can only be interpreted if x is 0 is a possible value for x, a value which is within the range of possible x values.